Hey class, this is Gigi from Kauai Community College. So this is a product rule problem when we are taking the derivative. We have the function f and we have the function g, and it is being combined by addition. So the product rule said that the derivative of the function f times the function g is derivative of the first times the second plus the derivative of the second times the first. Okay, so that's one thing we need to know. Another thing that we need to know is what the derivative is of secant and then what the derivative is of tangent. So the derivative of secant x is secant x tangent x, and the derivative of tangent of x is secant square of x. So those are the three things that we needed to know in order to do this problem. Okay, so here we go. The derivative of y with respect to x is the derivative of secant, which would be secant of x, tangent of x, multiplied by the second function, which is tangent of x. Okay, so that is, as you can see, this is the derivative of f multiplied to g, plus, now we need the derivative of g multiplied to the function f. Okay, so the derivative plus the derivative of g, which would be derivative of tangent, is secant square of x multiplied by f, which is secant of x. So we are looking at dy dx being secant times tangent square and then secant to the third power. Secant of x times tangent square of x plus secant to the third of x. Now, it depends on what we want to do here. We could try to simplify all the trig using trig identity, right? So what I can see is that, well, it depends on if you want to change tangent in for secant, or if you want to change secant in for tangent, right? So I think I'm gonna, since I already wrote this down, I'm gonna go ahead and change tangent square. So what do we know about trig identities? We know sine square of x plus cosine square of x is equal to 1. So if we go and divide everything by cosine square of x, then we have tangent square of x plus 1 is equal to secant square of x. So that means tangent square of x is secant square of x minus 1. So I'm going to go ahead and trade in that for this. So when we look back, we would say dy dx will equal to, and if you take secant square, times secant, you'll get secant to the third of x minus secant of x plus secant to the third of x, and that gives you two of those copy, right? So you have secant to the third plus another secant to the third, so you have two secant to the third. And then you would actually have a different looking answer if you would have traded secant square in for tangent square plus 1, then you might have a different looking answer. So in these problems, you just have to know when to stop, use your trig identity as possible, and your answer might be different than someone else's answer, looking differently, but it's still going to be the same answer. Okay, that's it.